We're going to do a little pre-teaching for Module 5 functions. In a point, xy, you have both the x and the y values. In the slope, you have the m value. And you have the equation y equals mx plus b. We are going to plug in an x. We're going to plug in a y and the m value. And we're going to solve for b. So over here on this side, remembering that this is our x, this is our y, we're going to replace the y value, we're going to replace the m value, and we're going to replace the x value. Now for some of you right here, you may have freaked out because you don't know how I came up with this. So negative 2/3 times negative 3, remember that is negative 3 over 1. Negative times a negative is a positive. We multiply straight across. That will get us 6 over 3, which simplified is 2. So that 2 is where that came from. And in order to solve for b, we subtract 2 from both sides, and we get b is equal to 2. Okay, so let's come over here. So, remembering this is my x, this is my y, and we have y equals mx plus b. So I'm going to replace the y with negative 3, replace the m with 4, and replace the x with 0. When I do that, 0 times anything is 0. So I get negative 3 is equal to b. Next, I'm going to do the exact same thing. I'm going to replace y with 12, m with 3/4, x with 0, and we have plus b. Again, 0 times anything is 0, so 12 is equal to b. Y equals mx plus b. I replace the y with negative 12. Negative 12, I mean negative 17, equals m, which is 0, x, which is 0, plus b. So negative 17 equals b. Now, I purposely used these first ones like this because you should have actually known the information already. Because anytime we have 0, comma, and a number, this is the y-intercept. So you should have known that off the top of your head. But I proved it that you can plug it in and find it anyway. So we're going to do this one. We are going to replace y with 3, m with 8, and x with 5. I get 3 equals 40 plus b. So we have a little more, we have an extra step. We have to subtract 40 from both sides and get negative 37 is equal to b. This one, again, we're plugging it into y equals mx plus b. I replace the y with negative 1. I replace the m with 7, the x with 2, plus b. Negative 1 equals 14 plus b. I subtract 14 from both sides. I get negative 15 equals b, and voila. Here, y equals mx plus b. 3 equals 1/2 times negative 4 plus b. Negative times a positive is a negative. Half of 4 is 2. I add 2 to both sides, and I get 5 equals b. Number 7. Again, y equals mx plus b. Replace my y with 11, my m with negative 1/5. My x is negative 10 plus b. So I get 11 equals, negative times a negative is a positive. Now some of you are still having trouble with multiplying fractions. Okay, I multiply across, I get 10 over 5, which is 2 plus b. I subtract 2 from both sides, and I get 9 equals b. Then I have y equals mx plus b. I'm going to replace the y with 9, the m with negative 1/8, and negative 16 plus 9. So negative 9 equals, negative times negative is a positive. So 1/8 times 16 over 1 would be 16 over 8, which is again 2. Why did I put, you guys aren't here to help me. That should be plus b. I have no idea why I put a plus 9. I subtract 2 from both sides, and negative 11 equals b. Normally I do that if when I'm multiplying something it's going to get that number, but that wasn't even the case. Y equals mx plus b. Replace the y, replace the m, replace the x, plus b. 0 equals negative 48 plus b. So I add 48 to both sides, and I get 48 equals b. Down here, y equals mx plus b. I replace negative 8, negative 3, negative 5, plus b. So negative 8 equals 15 plus b. Negative 15, or subtract 15, get negative 23 equals b. Number 11, y equals mx plus b. 7 equals negative 2/3. My x value is negative 6. My b value is what I'm going to find. So negative times a negative is a positive. 2/3 times 6 over 1. Multiply across, I get 12 over 3. That would be 4 plus b. Subtract 4 from both sides and get 3 is equal to b. Okay, y equals mx plus b. Replace the y, replace the m, replace the x, plus b. 3 equals negative 90 plus b. Add 90 to both sides and get 93 is equal to b. I can't get it all, but there you are.